Using the Ti-84 graphing calculator to find matrix addition, matrix subtraction, and scalar multiplication of matrices. Southwestern College, Professor Maria Olivas. In this video, we will be covering matrix addition, matrix subtraction, and scalar multiplication of matrices. We will be working with the two matrices that are on the right-hand side of the screen, matrix A and matrix B. Both matrix A and matrix B are of order 3 by 2. What this means that both of these matrices have 3 horizontal rows each, and they both have 2 vertical columns. In order to add matrices or subtract, they do need to be of the same order. I will list off the entries in each matrix by row from left to right. Beginning in matrix A. In matrix A, row 1, we have entries 1 and 2. In row 2, -2 and 0. Row 3, -3 and -1. In matrix B, in row 1, we have entries 1, -1. Row 2, 1, 3. Row 3, 2, 3. So now we're ready to input our matrices into the graphing calculator. So we will begin by going and hitting the second button, which is the blue colored button on the left-hand side of your graphing calculator. And then we need this matrix feature. This matrix feature is right above here, the button that says x raised to the -1. So this is the button we're going to press. This takes us to this matrix menu. We have 3 submenus here where it says Names, Math, and Edit. We're going to scroll over 2 times to the right, so press the right arrow key twice until the cursor lands on Edit. Then we're going to press Enter on number 1 to be able to edit the first matrix here, matrix A. The default order for a matrix here on your graphing calculator is order 1 by 1. So first we need to change the order. We're going to change that to 3 by 2. So first we'll press 3, then Enter, and 2, Enter. And now what you see here is we have created a matrix with enough entries, right, to put in the entries from our matrix A. In the first spot, you're going to notice here at the bottom of the screen for your graphing calculator, it says A and then it says 1, 1. What this 1, 1 represents, it represents the first row and the first column. So it basically says this is the entry that's going to go in the first row, first column, and we can call this entry A11. So we're going to input 1, Enter. Okay, now going on to the next entry, which is going to be in row 1, column 2, will be 2. And so on. I'm not going to list all of these names of each entry for like A21. What I'm just going to go ahead and say is I'm going to input the entries for row 2, and I will input them from left to right. So here we will input -2, Enter. 0, Enter, and those were the entries for row 2. For row 3, we're going to input -3, Enter, and -1, Enter. Now we're going to go second, Quit. Now we're going to go back, second matrix, and this time I'm going to still go to Edit, Scroll over twice to get the cursor to land on edit, and this time we're going to scroll down to the number 2 where it says matrix B. Press enter. Once again, the default order for the matrix here is 1 by 1. We're going to change that to 3 by 2. Alright, so for B11, our very first entry in row 1, we're going to put 1. And then that second entry in row 1 will be -1. In row 2, we will have 1 and 3. In row 3, we will have 2, 3. Now we can go second, quit. Now we're ready to add our 2 matrices. So we're going to go second matrix and press enter on 1. We're under the sub menu where it says names. We're going to press the plus sign, second matrix, scroll down to 2, press enter, and now we can press enter, and this is going to give us the sum of the 2 matrices. So the sum of matrix A and matrix B is this matrix of order 3 by 2. The entries in row 1 for this matrix are, once again, I will list off by row and then from left to right. Row 1 is 2 and 1. Row 2 is -1, 3. Row 3 is -1, 2. And if I were to add these 2 matrices, let's go back to second matrix. I'm going to add them this time. I'm going to switch the order. I'm going to add B plus matrix A. You're going to notice that the sum is the same because matrix addition is commutative. So the order in which you add the matrices does not matter. You will still come up with the same sum. Now let's go ahead and subtract them. We're going to go second matrix, enter on matrix A, and then subtract, second matrix, and then we're going to scroll down to matrix B, enter. And the difference of these 2 matrices is going to give us this 3 by 2 matrix. So once again, I will list the entries in the matrix off by row and from left to right. In row 1, we have 0, 3. Row 2 is -3, -3. In row 3, we have -5, -4. If I switch the order of the matrices and I decide to put matrix B first, and then subtract matrix A, I get a different matrix. So the matrix B minus matrix A gives me, I still get an order of 3 by 2 matrix. The row 1 is going to be entries 0, -3. Row 2 is 3, 3. And row 3 is 5, 4. Matrix subtraction is not commutative. Now let's go ahead and do scalar multiplication of a matrix. I am going to multiply matrix A by 3. So let's go ahead and press on 3, and then we're going to press on the multiplication symbol, times, and then I'm going to go second matrix and press enter on 1 for matrix A, and then press enter. And here we have the scalar product of 3 times matrix A. It is a 3 by 2 matrix. So once again, the entries by row from left to right. Row 1 is 3 and 6. Row 2 is -6, 0. Row 3 is -9, -3.